Okay, welcome back. Chapter 1, Section 4, Measurements. So far, this chapter has been pretty easy. But with Section 4, we're really going to kick things up a notch. Measurements represent a sort of trinity. There are always 3 portions to every measurement. 3 components. 3 different factors that make up every measurement. First up, there's the actual number. Okay, the actual value of the measurement. Next up, we have the magnitude, the size of the measurement. And that's an important distinction to make, because compare, 1.03 centimeters versus 1.03 meters. A centimeter is fairly short, about the length of the tip of your pinky finger. A meter is much longer, about the distance from the tips of your fingers to your nose with your arm outstretched. But 1.03 centimeters versus 1.03 meters, or for that matter, 103 centimeters or 103 grams, those have the same amount of information, just at different sizes, different scale, different magnitude. And finally, the unit. Okay, the unit of the measurement tells you what kind of thing you're measuring and how you're measuring it. So centimeters tells you that you're measuring length, and you're measuring a short kind of length. Meters tells you that you're measuring length, and you're measuring a fairly long kind of length. Whereas grams tells you that you're measuring mass, apples to oranges. So you need all 3 of these things in order to have a proper measurement. You need to know the actual number of the measurement, you need to know the size, and you need to know the units. If you're missing any of those things, you don't really have a measurement. And I really want to hammer this home, magnitude versus number. 1.03 kilometers has about the same amount of information as 1.03 centimeters, just at very different scales. Okay? You have those 3 digits there. You have the same sort of level of precision in both of those measurements. 1,030 meters has as much information as 1.03 meters, or 0.0103 meters. Okay? The difference is the scale of the measurement. So the device being used to measure those things, whether it's 1.03 kilometers or 1.03 centimeters, allows you to get those 3 digits. It gives you exactly the same amount of information. But notice that you have those different zeros. The final 0 on 1030 is only there as a placeholder to show the size of the number. And the first 2 numbers in 0.0103, those are just there to show that that number is small. So those numbers don't really give you information about the measurement itself. They're there to give you information about the size, the magnitude of the measurement. So they're a different kind of information from the actual measurement itself, the number that you're getting. So we make a very important distinction there between the different kinds of information you can get out of the measurement. So one kind of information is the number, the other kind is the magnitude, and finally, the unit. 3 different pieces of information that all have to be there to have a good measurement. You have to have the units. You have to be very, very careful about that. Because different units measure different things. Or they can measure the same thing in different ways. You don't have units, you don't have context. The measurement becomes meaningless. Or it can just be plain wrong. Always, always include your units. A lot of science means being very, very careful in ways that are fairly difficult for most people to do, even scientists. You have to write everything down. You have to be careful. Keep track of everything. That's difficult. But then, if science was easy, little kids would do it. So that'll do it for the first part of Section 4. See you next time.